Morning. Mr. Lisham is here, and we are finally going to end the parabola section in this function, function chapter. And I just want to start with a quick recap. So far we came across two forms, okay, of quadratic functions. So I can write a quadratic function like that, or as we saw in the last lesson, we can write it like that. They're both quadratic because I always end up with the x squared. Each one of these forms are good for different things. So if I look at the first one that we started with, there's certain things that I can find which are really easy, okay? And well, there's one main thing, and that's to find the turning point, okay? And I don't think I ever wrote it for you, but we can use this to find the turning point. Oh, okay, you know what? Let me just start maybe somewhere slightly different where I did talk about, okay? Because I know what these P's and Q's are, okay? We mentioned that a few. What is the P? Horizontal shift. Horizontal shift. We spoke about it. And Q is the vertical shift. But if you think about that, if you know what the horizontal and vertical shift, then you're taking your, basically what you're doing, you're taking your mother graph and you move it Q upward or Q downward, whatever Q is, and you move the P to the right or to the left. So we can tell now what is the turning point very easily from it, okay? What is the coordinate of the turning point? I'm going to put that question and see if I can get something for me. Alright guys, so we got some kind of interesting discussion. Let's say that this is my mother graph, okay? Right? And if I know what the specific, look, we're having a bit of a general theoretical discussion, and that's often quite difficult. And it's not too essential, but for now, I just like to do that, okay? So my original function, y equal x squared, was here. The turning point, what was the coordinate of the turning point? 0, 0. Now, that's been moved now. If I give you the P and the Q, it's been moved. In this case, to the right and up. But obviously, if P is positive, then actually moves to the left, right? Positive P moves to the left. If Q is negative, is moving to the down. So it could have been here. What I'm trying to find out, what are the coordinates of the turning point? Okay? And what I'm saying is, the turning point, I'll call it XTP. Okay? We'll call it XTP. The coordinate, the x coordinate of the turning point. Okay? That's being moved minus P. Okay? I'll show you that with an example. Let's say I have y equal 2x plus 3 minus 1. Let's look at that example, okay? What's the x coordinate of the turning point? How much did we move this? To which direction first? Left or right? To the left.
Left.
To the left, because that's plus. When it's plus, we move to the left, right? It's kind of the opposite, okay? Plus, move to the left. Minus, move to the right. What's the coordinate now? How much did we move it to the left?
3.
We move it 3 to the left. In other words, x is equal minus 3. The turning point is x minus 3. You see, whenever this thing is 0, that's where you get the turning point. So the x coordinate of the turning point is minus p. Okay? This is something worthwhile remembering. The turning point will occur here when this thing is 0. Okay? I'll answer the question in a bit. What about the y? What is the y turning point? This is easier, and you actually gave me the answer. Y is the q, because originally it was at 0, 0. Now I know I've vertically shifted it up or down, q way. So the turning point is q. So more importantly, guys, because I know this is very difficult with general discussion, let's think about the turning point here. The turning point in this, okay? The x will be equal to minus 3, and the y turning point will be minus 1. Okay? If you think about it, we had that discussion in the beginning of the year when we talked about completing the square. When we were looking at the minimum values of quadratic equation, it's exactly the same thing. What is the minimum value of the y here? It's going to be minus 1. Why? Because this thing is always forever positive, because it's squared. So this thing is always going to be positive. So the smallest thing that this can be is 0. 0 is not really positive, right? This thing can never be negative, but it can be 0. When will it be 0? When x is equal to minus 3. What will be the y then when this is 0? Minus 1. So the turning point coordinate of x is minus p, and the y coordinate is q. I'll pause here and see if you've got any question.
So you just put it in like that because you don't time anything by it?
Yeah. If I give you a form like this and I said, Simon, what is the x-intercept? Oh, yeah, x-intercept. You tell me. 2 and minus 1. Okay? But the questions normally will be more difficult than you'll see now.
Yes.
What day is Wednesday? Catch up Wednesday. Fine, we don't need to start hyperbolus. We are going to catch up. Catch up. We are on pace. We are on pace setter. We're not behind.
Yay.
I wrote it down.
When do we finish, guys? What time is Funky Wednesday? Okay, I better, can I move on? You're writing. A few seconds, are you happy? Yes. Okay. Is this on? As I said, we're not really done because even though this is true and this is in this form, you should never really write a full answer as this. Because what do you think we should write down? What should we do now? I think you have some good idea. What should we do now? We need to FOIL it. We need to simplify it. Unless they tell you specifically you can leave your answer in this form, you should really always get to that form, which is completely FOILed, simplified. Okay? So it's going to be 2. I'm going to leave the 2 out. I'm going to first of all multiply these two brackets. Okay? I'm going to do it quite quick because we're running out of time. It's going to be x squared minus 3x plus x minus 3. Okay with that? I just multiplied the normal, nothing fancy. Then I'll keep the 2 there. I've got minus 3x plus x, so I can write as x squared minus 2x minus 3. And finally, I'm going to write it down here. Y equal 2x squared, I'm just multiplying the 2 now, minus 4x minus 6. Okay? Right. Now, before we end this video, there was a question here. You asked about the turning point. They didn't actually ask to find the turning point. In theory, if I want to find out the turning point, actually there's something I can do very easy. How do I find the turning point? I want to find the turning point. Yeah, you know how to do that.
Negative b over...
Negative b. What is negative b? It's 4 divided by 2a. So it's equal to 1, right? You know, yeah? Yeah, substitute together. But hang on. Let me just show you one more way to do it. It's just something that might help you later on. And this is only true for quadratic equations. How can I tell that the turning point here is minus 1? I want you just to ask, you think, how do I know this is minus 1? This is minus 1, this is 3. How do I know this is minus 1?
It's that bang in the middle.
Bang in the middle, well done, Bruce. Not minus 1, I meant plus 1. Okay? The turning point, only in quadratic parabola, quadratic equation, is bang in the middle between the two roots. So that's another little cool thing to do. Because it's the line of symmetry, of course.
Oh, wow.
Okay. I'm going to stop this video and homework, Bruce. I haven't given you homework yet.